So picture this. You're working in Marvel's Designer and you're spending time to create an awesome garment and you're very proud of the work that you have done. And you feel as if most of it is pretty much to your liking and it's pretty much complete, but perhaps there's a few things here and there that you'd like to tweak. Maybe there's a few folds, perhaps around the elbow that you feel you could add. Perhaps there are other folds elsewhere that you would actually rather get rid of. Or there's just some type of details left and right that you would like to tweak somehow, either by adding details, removing details, doing whatever it is that you want. But you do feel as if your garment needs a little bit of sculpting on top of it to get it to be 100% the way that you want it. Or perhaps that your garment is exactly the way that you want it, but you're not necessarily looking to bake it down to a low res. You just want to render it out. You want to apply a nice detail map that will tile over the garment. Perhaps you're not even making a game character, you're just making a character for your own portfolio just for the sake of it. Those are all situations where it is very useful to be able to export a garment out of Marvel's Designer and to have some type of very clean topology to continue to work with it or to render it out afterward. If you've created a character using Marvelous Designer before, you've probably faced a situation like this where you are done working in Marvelous Designer, but you're not quite sure what you are supposed to do now to get your garment out of the software into whichever other software that you want to continue with. And you're not quite sure about what are the steps involved and how to get a proper, clean, quadded topology for it. Because, of course, when we work within Marvel's Designer, our garments are usually some type of triangulated mess. So you need some type of pipeline, some type of workflow to be able to easily extract your garment out of Marvelous Designer into a nice, clean, quadded form. There's a whole lot of different approaches to that, but they usually all have some type of drawback, some type of limitation. And to be honest, for me, it's always been a weak point of working with Marvelous Designer, the simple part of exporting out of Marvelous Designer and throwing the garment that we are working on in whichever other software that we want to. It's always been very painful. And I've done my best in the past actually to try to come up with a particular workflow that you could actually follow, which was actually more a workflow that was more based for those who want to continue working on their garment within ZBrush. And I had actually put that
You
workflow down
mean
into a nice little image that looks like this here. So the Outgang pipeline to export from Marvel's Designer to ZBrush within a little cheat sheet that you can see right here. And this is freely available on outgang.studio. You don't even have to be a member to grab this particular cheat sheet, in fact. If you want to see that actual cheat sheet, you can go to the Learn page of outgang.studio, go to the class here that is called Exporting Out of Marvelous Designer. And in there is a link here that you can click on to access this particular cheat sheet. Accompanying this particular cheat sheet is, of course,
guys,
a
let's
lecture as well on outgang.studio as to how to
guys will
go about exporting out of Marvel's Designer, how to follow along the cheat sheet. And of course, you have to be a member to be able to watch that particular class. But I know that all of that particular cheat sheet and the actual video class that this is based off of has been extremely useful for a lot of you, because a lot of you have simply told me that how that particular cheat sheet has been extremely useful to help you export out of Marvelous Designer and understand the whole pipeline there to get your triangulated
And,
soup out of the software into some type of quadded form. But as useful as this
the
particular
stack.
pipeline has been to a lot of you, and I know that, of course, because a lot of you have told me so, I was always a little bit dissatisfied with this particular approach for a few different reasons. One is that to follow this particular pipeline, you need to go from Marvelous Designer to Maya, and then from Maya, you need to go to ZBrush. And I know that not necessarily all of you have access to either Maya or ZBrush. Some of you are Blender users and would like to continue working with your garment within Blender. So, of course, Maya and ZBrush are very expensive softwares, so that's one of the limitations. Second of all,
Today's
it's a little
class,
bit
it's all
confusing
about
because you
tertiary
have
details.
to
I have
make all
prepared
these
quite a lot of different.
decisions, which brings you into different paths of this kind of branching tree of decisions that you can see here. And that can get a little bit confusing. Also, this particular pipeline relies on using Z-Remesher from ZBrush to generate the actual quadded low res. And Z-Remesher really isn't perfect. It works great in a lot of cases, and there are a lot of other cases
because
where it actually creates a jumbled mess of polygons that really aren't nearly as clean as we would actually like them to be. So Z-Remesher really doesn't always work, and this particular pipeline lives and dies on Z-Remesher. So there's a lot of circumstances where a particular garment that you are working on is not actually going to work properly using this particular approach, all because of Z-Remesher. And two of the other drawbacks of this particular pipeline, and those for me are actually the biggest things, beyond just the fact that we have to go from ZBrush to Maya and then back to ZBrush. The things that always had bothered me are what I consider to be pretty severe limitations of this particular approach, which is that, first of all, there is an inherent resolution limitation to the kind of low res that is created. I'm not going to get into the details of that necessarily, but we can only generate a quadded mesh that would have ultimately 4 level of subdivisions if we were to continue to work on this particular garment within ZBrush afterward. And sometimes that's not enough to capture all of the details on a mesh. So that's one of the limitations. It is only limited to 4 subdivision levels. If you've used a pipeline, you are aware of that.
Let's zoom out.
And second of all, because we are using panel loops of ZBrush to generate the thickness of the mesh, we do not actually get proper UVs on the border. So when we add a little bit of thickness to the mesh, the polygons on the border does not actually have any type of UVs. And that's a big problem because maybe your goal is actually now is get your garment out of Marvelous Designer. And then, as I said, maybe apply some type of tiling detail on top. Maybe you're already very, very proud of the work that you have done here. And you don't necessarily want to go through the complicated process of making a very complicated low res and then baking from high poly down to a low poly. You just want to extract this out and then maybe just throw it directly within Substance Painter to texture it. Or maybe you just want to render it out. Maybe you're creating a portfolio piece, character for your portfolio, but that's not necessarily a game-ready character. You just want to make a character just for the sake of it. And you want to make a nice, clean, very high-quality render out of it. And so the fact that you're not gonna get any type of UVs on the actual thickness border of the cloth is actually a pretty big problem, because then it means that you cannot easily tile some type of detail map over the garment after you're done with it. Anyway, so if all this sounds like gibberish, it's probably because you haven't really gone through this particular process of extracting a garment out of Marvel's Designer, but perhaps you have been wondering how to do that. And if it does not sound like gibberish, then it means that you have gone through that particular process, and you've probably seen that even with a relatively simplified pipeline, it still usually is very complicated, and there are a lot of limitations that are inherent to whatever pipeline that you have followed there. All of that is to say that as I was working on this particular garment here that we have been exploring together in the context of classes on Agenda Studio, I've realized that the pipeline that I had set up myself to eventually be able to export this garment out of Marvel's Designer really was not sufficient anymore. And it was a good pipeline for a few years ago, but nowadays in 2023, and especially considering the fact that we now have Marvel's Designer 12 that has better retopology tools at our disposal to help us create a base for this particular garment, a low res, if you will. The particular pipeline that I have previously outlined here really wasn't going to cut it anymore. And I really wanted to figure out a better, faster, more streamlined, easier to use pipeline that also does not rely on having to jump through multiple softwares to be able to do something that should be relatively simple, which is to simply export a garment out of Marvel's Designer and get a clean topology out of it. And that would instead rely on free tools, in this case, Blender. It actually took me a few weeks to put this particular pipeline that I will show you and present to you and share with you. It actually took me a few weeks to put that together, a little bit longer than I actually thought. In fact, when I started to work on my new updated pipeline to export out of Marvel's Designer, I thought I would be done in about a few days. But Blender revealed some of its complexity to me in the process, and I had quite a lot of different bugs and little situations to fix. And there were also a lot of features that I wanted to add on top that I've never seen in this particular context that made it so that this job of redesigning a new updated pipeline to export out of Marvel's Designer, updated for 2023, actually took a little bit longer than I thought, and it took a few weeks. So if you are watching the classes on Agenda Studio as they are released, that's also why I haven't posted a few classes there in the last few weeks, because I was 100% focused on this. But I think that you will be very, very happy with what I have to share with you. I'm personally extremely proud of what I'm about to show you. I think it's what I'm about to present to you might just be the best pipeline ever trademark to export out of Marvel's Designer. And I don't say that as a joke, actually. I actually mean it. I think this might actually be literally the best, easiest to use pipeline ever designed. So I'm about to show this to you, and I hope that you will find this very, very useful. So what I've done is that I've created a series of geometry nodes within Blender that allows us to take a topology, the kind that we can generate easily using Marvel's Designer 12's retopology feature, which we'll talk about later. And I've created a series of nodes that transfers the details from the high poly onto that new quaded topology that you can see. So this is actually what it looks like. This is a test. And if I just unhide what is in the scene that is right here, here is my low res that if I hide the geometry nodes here and I show you what the wireframe looks like, you'll see that this essentially just looks like a quaded topology that's actually very basic. And on the left here, I have the high poly that has been exported out of Marvelous Designer. And so on this particular low res that you can see, if I turn my geometry nodes back on, you can see that the geometry nodes that I have both transfer the details over from the high poly onto the low poly. It subdivides the low poly in the process, and it also adds thickness. So the geometry nodes basically look like this. We have our input here, so we have our low res that is inputted right here. We have two nodes that I have created for the occasion. One that transfers and subdivides our low res and transfers the details from the high poly onto our low poly. And we have a second node that is right here, whose job it is to add the thickness. And there are a lot of options here that are very, very interesting for us that we will talk about. And then we simply output out on the other side. And that is done. This really just takes a few clicks to set up. It's very easy to configure. And if I show you actually what it looks like here with the UVs, you can see here what our UVs look like, even for the border. Let's just disregard what's happening on the high poly for now. If you take a look at the low poly that has been subdivided here, you can see that the border UVs are pretty much perfect. And if I turn on here the wireframe, you can see what it actually looks like. We also wind up having the number of subdivisions on the border that we actually need to be able to reconstruct this in whichever sculpting software that we choose to use afterward. Now, if you're primarily a ZBrush user, don't run away just yet, okay? Because this pipeline is actually very, very simple to use. Yes, you might have to use a little bit of Blender in the process, but ultimately, I think that this pipeline is actually a lot easier to use than what I had created in the past. And it's not because this is using Blender that you are limited to using Blender to continue working on this. Because when you are done with the detail transfer and adding the thickness to your mesh, you can afterward export this out back to ZBrush if that is what you want to do, and you can continue to work on it. The topology that we are getting here is specifically made so that we can continue to work on this after the fact with sculpting brushes. So whether we continue to work on this within Blender or within ZBrush. In fact, the mesh that is right here, I have already imported it within ZBrush, and you can see it right here. We have our thickness, as you can see. We have all the details that are there. Now, this has already been reconstructed, but if I just delete all the subdivision levels, this is essentially what we would import from Blender into ZBrush. And from here, we can simply reconstruct our subdivisions to go back to subdivision 1 and have our full subdivision history that is right here, so that we can continue working on this garment afterward in whichever way that we want. So even if your goal is to export from Marvelous Designer to ZBrush, This pipeline, although it does go through Blender, I still actually think that it is the best pipeline that you will have at your disposal to be able to cleanly export out of Marvelous Designer. I'm going to show you a few of the features that I have built within these geometry nodes so that you can see what it can do right away. And then, of course, we will talk about the whole pipeline and we will break down all of the features that are in there. But just to give you a little bit of a taste here, let me just open the geometry node editor right here. And we can tweak a few of those settings that we have within our geometry nodes that are here, especially on the cloth thickness. So I just want to show you a little bit of what it can do. First of all, actually, we have, if I actually move on to the cloth transfer node that is right here. First of all, actually, we have access to this subdivision slider that is right here. And you can see here, as I play around with these subdivisions that are right here, we are going to go from what was the original mesh, that the original retopology that we had exported out of Marvelous Designer, which was created using Marvelous Designer and using the retopology tools that are in there. And here I can add subdivision levels. And as I'm adding subdivision levels, it will transfer both the details from the high poly over. Let me go back here to untextured. It will transfer both the details from the high poly over in the process, and at the same time, it will subdivide the thickness border so that we have the exact number of edges on the border as what we would need to be able to reconstruct this afterward within either Blender or within ZBrush. I've set it so that we can go up to 5 subdivision levels. This is actually one more subdivision level than what is technically possible to do using the old pipeline using ZBrush that was limited to 4 subdivision levels. But in this particular case, we can go up to 5. And other than that, if we move on to the cloth thickness node that is right here, that is attached to it, we have a few features here that are very, very interesting. First of all, we can, of course, play with the actual thickness using precise measurements here in millimeters. So right now here, you can see that my thickness is set to 2 millimeters. I can set this back to 1. And now you can see that we will have 1 millimeter of thickness for this particular cloth. Of course, I'm doing this right now with a garment that is still hooked up here to the cloth transfer node. This can become a little bit slow when both of these are hooked up. So if you are going to do some heavy tweaking of these particular values, one thing that we can do, of course, is to simply collapse the geometry nodes with the first cloth transfer applied, and then afterward apply the cloth thickness afterward. So I'm actually going to do that just to speed up here Blender a little bit. Let's go ahead and do that. So this is going to speed up Blender, of course, because we do not have to recalculate the actual transfer every time that we change some of the values that are here. And so just to show you what it does, essentially, we have, first of all, a slider here, of course, that controls the thickness of this particular garment. So if I set this to 2 or set this to 1 again, these are using precise millimeter values. We can choose the type of profile that we want here. So if it's set to 0, we will get this nice rounded profile on the border. But I could set this to 1 here and get a profile that's kind of shaped a little bit like 2 pieces of cloth that have been sewn together. And I have actually added this in because we have that option within Marvel's Designer. In fact, if I just show you here, and if I just select a random panel right here, I can take any of these panels and I can set it here as double-sided. And you can see the kind of effect that it does right here on the border. It's a little bit hard to zoom, but you can see how it creates the impression that we have two pieces of cloth that are sewn together. So within our geometry nodes, then we have the same option by simply changing the type of profile that we have. And there is also a profile that will give us something that's a little bit more square. If we want a mesh that's going to be a little bit lighter in the end, we can turn off this little checkbox here to get rid of the polygons that will be on the underside of the mesh, because sometimes we don't necessarily want those. And if I show you the UVs here once again, so we get UVs on the border that have no distortion. Just for the sake of demonstration, let me get a very thick profile here. So you can see how big the profile is right now. And you can see what the UVs actually look like. So the UVs actually extend out as we increase the thickness here. If I say, let's say, if I set, let's say, the thickness here to, let's say, 5 millimeters, you can see how the UVs also extend out. So we always get UVs that are distortionless. And if you're curious what the UVs of this actually looks like, I can show you. Let me apply this particular geometry node. And let's go afterward to the UV editor. And you can see the panels that I have right here. And you can see as I zoom in, you can see what is happening. So our original panels, of course, did not have a thickness. The thickness has been added through code, through the geometry nodes. And you can see what is happening here. All of these extra polygons that we have here are all the polygons that have been added for the thickness. And the UVs have been extended out so that we get nice UVs that do not have any type of distortion and are perfect for UV mapping, for texturing. And also, one thing I want to note is that this garment was actually built using a lot of disconnected panels within the Marvelous Designer. So let's say that we are looking now at the cross section. You can see that this is not the complete retopology. It's only part of this particular garment. But if you take a look at what is happening right here, so on the inside, so this is the sleeve that is right here. And if I show you within Marvel's Designer what this actually looks like, you can see that I actually have a series of panels that are right here that are all disconnected and that are kind of flowing and connecting to each other in a bit of a S curve, if you will. So the outside panel here is a separate panel from the one that is right here, which is a separate panel from the one that is right here. So we get all these disconnected panels within Marvelous Designer. A lot of this garment is created out of disconnected panels. If you look at my retopology here once again, you can see that some of these panels have actually been welded together. Here's the topology. So this has all been welded together. So we have the choice to weld together whichever pieces of the garment that we want. We can, of course, keep all these panels disconnected too if we want. We have that choice. We can choose to either weld parts of the garment together or not to simplify our life later on when it comes to sculpting on top of this particular garment. And you can see how the details have been transferred very, very, very cleanly. It actually took me a long time to write the proper code and fix all of the bugs to really get this very clean transfer that we can see here from of the details from the high poly to the low poly. It took a lot of work to get here, but I'm extremely proud of the work that I have done. And if I go ahead here and just collapse these geometry nodes, we can see that if we want to continue on this within Blender, and let's say that we want to sculpt afterward on top of this, we can do it just as well as if we wanted to continue sculpting on top of this using ZBrush here. I can just go here, apply a multi-res modifier, and I can unsubdivide, and I can go back down to my lowest subdivision level, and we can use our sculpt brushes in here just as well to continue working on this particular garment. If there are folds that we want to add, folds that we want to remove, details that we want to tweak, we can do this very, very easily and very cleanly now. I've tested this out with a range of garments to make sure that I was catching all the bugs and making sure that I was really developing something that was going to be very useful in the context of a lot of different garments. And I'm very happy to say that even on this particular shirt here, which is a lot more challenging because there's a lace here that you can see, and there are also pleats on the sleeves, as you can see. So the sleeve is inserting within the rest of the torso here using a few pleats that are here. I can show you what it looks like within Marvelous Designer. So you can see the lace that is right here. You can see these pleats that I'm talking about. We have other pleats too. We have a gather that is around the wrist. And these laces are actually little disconnected pieces here, as you can see. So they're all little disconnected pieces of geometry. They're all disconnected panels because it was easier to build it like that within Marvelous Designer. We have a class on that, of course, on Studio, which is still very relevant today. So if you're wondering how these lacings have been constructed, we have a class on that on Studio for you to watch there. And I was able to follow the exact same pipeline. I've used Marvelous Designer's retopology tools to create a quick topology for this particular garment. And I really wasn't even very careful to create a very nice, clean topology. You can see I have a bunch of triangles in different places. And there's certainly places where this garment could be improved. But the goal was to work relatively quickly, see if I could actually create a topology relatively quickly using Marvelous Designer that would afterward give me a very clean transfer afterward, even for very complex details such as pleats and laces. And you can see, even though in Marvelous Designer, our laces are all these disconnected little pieces of geometry, we get a lace here that is one continuous and very clean piece of geometry in the end. And even for things like pleats, we have our topology here that is folding over itself, and not a problem for these tools. They deal with that very, very, very nicely. If I go ahead and show you what it looks like with the thickness afterward on top of it, this is what it will actually look like. So we just add the thickness here on top. And then once again here, we could say, let's say thickness perhaps 1 millimeter. And you can see once again, look at these laces, how nice they actually look. And once again, our UVs have been extended very nicely from the border. We have to tweak our little UV padding multiplier here in this particular case here once again. And if I play around with this here, so value of maybe 0.3 would work pretty well for this particular mesh. And you can see how the UVs look on our laces. Here are the gathers. This gather that is around the wrist of the character, I have actually merged it. So I have merged the low res. This is what the low res actually looks like for this. So this is what the low res looks like. And I have merged the gathers within the same topology, the same mesh as the rest of the sleeves for this particular garment. And even if everything here is welded together, we still get all these great details that come out very, very clean after the transfer is done. We do have a little bit of artifacting over the surface. There's a few little pinches that seems to be on the surface, but that's actually all coming from Marvel's Designer. None of that is coming from the tools. And in fact, even here, if I look at the sleeves, you can see that there's a little bit of a noise on the surface of the mesh. And that's not even coming from the transfer itself. That's actually coming from the Marvel's Designer simulation itself. What we are actually seeing at this point is the triangles and the original vertices that were exported out of Marvel's Designer. And if we want to get rid of these things, then we simply just have to do a very slight smooth on top of our surface using a few sculpting brushes afterward, either within Blender or within ZBrush to get a perfectly clean surface. So I'm convinced that you will find this pipeline to be very useful to use, very easy to use, very fast, and that it will give you some great results. And really, the only thing that you need is these two geometry nodes for Blender. You just need to get them, install them on your computer, and then you can apply them to whichever low res that you have that has been exported out of Marvel's Designer to do the whole transfer of details and add thickness. So it's extremely simple to use, but it is extremely powerful. And I'm distributing all of these nodes to all our gang members. So if you're a member on the platform, you can go and download a Blender file that will contain these nodes that you can then afterward install on your computer and unlock for yourself this whole pipeline. You can go to the website, go to your account page, go to the handouts tab afterward on your account page of outgang.studio. And within the handouts, within the Blender section of the handouts, you will see a link to download this particular blend file. I'm recording this class after I have finished version 1.0 of these particular nodes. And if there is any need in the future, I will release future versions of these nodes. So by going to outgang.studio, going to the handouts page, you will be able to download the latest version of these nodes. There might still be bugs, there might still be things to improve, and perhaps you even have ideas as to how I can make these nodes even better in the future. And if that's the case, I really want to hear it. So either do leave a comment within the particular class page, which you are watching right now, or perhaps send me an email info@outgang.studio. If you have any suggestions, if you have any problems, if you have any tips, if there is anything at all that you want to communicate with me about, send me an email or leave a comment on this class. Okay, so what's on the menu for us today is to go through how to use these nodes from A to Z, starting from a garment within Marvelous Designer that is at the high poly stage. So before we have any type of retopology for our garment, exporting it out of Marvelous Designer, talking about the settings that we need to set to export it out properly out of Marvelous Designer, importing it within Blender, tweaking the mesh, and then using those nodes. So do look at the chapters that are on this particular class if there is something specific, if there is a specific moment to which you want to jump to. Go ahead and do that. Use the chapters. They are at your disposal so that you get quick access to the information that really matters to you. I'm going to first start by talking about how do we install these nodes on our computer. So perhaps you've gone to the handouts page and you have downloaded the blend file that you need. So the Outgang cloth nodes blend file, perhaps you have downloaded that, but perhaps at this stage you don't actually know what to do with that particular file. So let's talk about how to actually install that so that you get access to those geometry nodes on your side. And if you've never used geometry nodes yourself, I will also show you the basics of how that works. We're not going to do geometry nodes together in this particular class today, but I will at least show you how to grab those nodes and how to use them on your side if it is the first time that you do touch geometry nodes within Blender. So the first thing that you need to do then, after you have downloaded the blend file that contains these nodes, is to choose where on your computer you want these to be stored. Because we're going to make use of Blender's library option to install those nodes at a particular path on our computer that we choose and that we can afterward quickly access in whichever other file that we could be working on within Blender. So really the first choice that you have to make is where do you want your library to be if you don't already have one that is set somewhere. On my case here, you can see that I'm working from my D drive, projects, Blender, library. It's a folder I have created and in which I will put other Blender files that I could want to use in the future and that I could want to always have quick access to whatever it is that is within those files. It is also very important for me to mention that these nodes have been created using the beta version of Blender 3.5 because there were a few features in there that I really needed to make these happen. So these actually could not have happened on previous versions of Blender. So Blender version 3.5, which at the time of recording is currently in beta, is also a requirement for you to be able to use those nodes. So if you're using a previous version of Blender, I suggest that you update your Blender version to Blender 3.5 or later to be able to use those nodes. Blender 3.5 is supposed to be released in a little bit less than a month at the time of recording this. So at whatever time you are watching this particular class, this might not be a problem for you. But if you are watching this class shortly after release and you want to grab the beta version of Blender 3.5, you can do that by going to builder.blender.org, and there you will be able to see a link there to download the beta version of Blender 3.5. You can go ahead, download that, install that and start using that. Once we have Blender 3.5 or later that is ready to use, we can launch Blender and we can go within Edit and within Preferences to be able to configure the path to our library. Within Blender Preferences, let's go to File Paths, and then let's scroll down here. And eventually you will see a little box here that says Asset Library, User Library. If this does not exist for you, you can simply click on the plus to add a new path that will be a library path on your computer. And in my case here, I need to actually switch this over to my library right there. So I have my path here set to my library path, as you can see. And where it says import method here, I will actually switch this over to link, which is just a default import method for anything that you are using within the library, which means that if the code within the original nodes change, that change will be automatically propagated to whichever scene are using those nodes. So personally, I just like to work like that, but you can choose to work in whichever way that you want, really. And if I take just the default cube that we have within our Blender viewport, I can go then to the modifier properties by clicking on the little wrench that is right here. I can add a modifier. In our case, we will add a geometry nodes to our cube. Of course, adding thickness to a cube might not be the best thing to do in this particular case, but just to show you where those nodes that we just have added are currently living. Let's add a geometry nodes, then modifier to our cube. Let's click on new to create a new set of geometry nodes. Afterward, let's go to view, let's go to area, let's go to duplicate area into new window to open a new window for Blender. On the top left, let me switch the editor type from our 3D viewport to the geometry node editor that is right here. And this allows us to create or edit geometry nodes that will be applied on our object. Let me move the group output here out of the way. And if you want to access those nodes that we have just installed, you can press Shift A on your keyboard to bring up the search box. Click where it says search. And then afterward, type in Outgang. And you will see the two nodes that we have installed within our library that will show up right here. First, we have our cloth transfer node, and then we have our cloth thickness node. And we can hook them up to our cube by connecting the green geometry output from the group input that is right here. Connect it to the geometry input on our Outgang cloth transfer. Hook up the two geometry connectors that are right here. And finally, connect the output geometry connector from the Outgang cloth thickness all the way to the group output node. Now, of course, this is not really going to do much on our default cube. I mean, it's going to subdivide it and it's going to add a little bit of thickness to it. But of course, this will be a lot more useful once we work with this in the context of cloth. But that is the basic workflow to use these particular nodes. And that's how you install them. So of course, to use these nodes, we have to start by exporting data out of Marvelous Designer, of course, so that we can use it within Blender afterward. And we need to export two things from Marvelous Designer. First, we need to export out our high poly, which we are currently looking at. And we also need to export out a low poly topology that has been created using Marvelous Designer 12's retopology tools. If you have not used Marvelous Designer 12's retopology tools up until now, you will find them within your 2D pattern window on the 2D toolbar, and they look like this. So this little icon that is right here will allow you to access the topology tools of Marvelous Designer 12. And I will give you a demonstration of how to use those in the context of this particular class. I will show you how to create your low poly topology using Marvelous Designer 12. But I will actually do that at the end of the class. Okay, so if you want to see that, if you want to see all of the steps one after the other, and you want to see how to use the topology tools of Marvelous Designer 12, there is a chapter at the end of this particular class that you can jump to see how we will use the topology tools of Marvelous Designer 12 to create this retopology that we are looking at. But I'm keeping this for the end of the class because I think that this might not be necessarily what all of you want to see right now. I think a lot of you want to see what is the full pipeline and how do we use these particular nodes. So because of that, I don't want to get bogged down into retopology just yet. So let's talk about how to export our data out of Marvelous Designer and what are the settings there that I like to use, that I recommend for you, and how to go about doing that. These geometry nodes rely on transferring details through UV space. And that's why they're able to deal with things like undercuts in the context of pleats. The details get transferred through UV space. So it is extremely important that the UVs for our low poly and our high poly match perfectly, because if they don't match, then this whole tool will simply not work. So we're going to make use of Marvelous Designer's UV editor here very, very briefly. And before we even export high poly first, the thing that I would recommend for you to do is to simply pack your UVs in a very neat way. Now, unfortunately, Marvelous Designer makes it a little bit hard for us to pack our UVs properly because any changes that we could do to the packing within the UV editor, so we can technically take our shells here and we can move our shells around. But the problem is that the moment that we will extract the topology out, our UVs will actually reset. And that's a big problem. That's a big limitation of our Marvelous Designer. It would be great for it not to do that, but at the time of recording, Marvelous Designer does that. So to make sure that we don't have any kind of problems of panels jumping to different positions once we extract the low res out, what I simply recommend to you to do, which is a very foolproof way of going about this, is to simply start by packing together all of your panels relatively neatly. This tool really doesn't care too much about the ultimate resolution of your UVs, but it will make your life a little bit easier if your UVs are arranged in a square-like fashion to begin with. It's really not necessary at all, but I think it just leads to a result that will be just a little bit cleaner afterward. But again, not strictly necessary. And also, thing that is important at this particular stage is to keep a little bit of a gap in between those different panels. One of the limitations of these geometry nodes, we cannot have in any way overlapping UVs on our high poly. So it's very important that there's a little bit of a gap within our different shells. It doesn't have to be a big gap, but we just want to have a little bit of a gap between our different panels. Because the panels that are overlapping will simply not transfer properly. It's okay if you do have overlap somewhere. It's just that what's going to happen with those panels that are overlapping is that they will not be able to transfer details from the high poly over to the low poly. Everything else will work, but you won't get any detail transferred for any panels that are overlapping within Marvelous Designer. This really isn't in any kind of way a proper backing if we wanted to somehow do a character for video games. But the goal really is just to have something that's just somewhat manageable and not have everything spread out over a very, very large distance within our 2D editor window. Anyway, so once we're done with that, let's go to our UV editor afterward. And in here, let's do a right click within an empty space here of our UV editor. And let's do a reset UV to 2D arrangement, which effectively resets these UVs to match exactly like what they were looking like within our 2D editor. And then afterward, let's do a right click again. And let's do a fit all UV to 0, 1. And we can put here a very, very small value. This might be 0 by default. You can go here for a very, very small value. It's just going to add a little bit of padding between your different UV shells and the border of the UV editor. But it doesn't really matter too much what value you put there, as long as you remember what this value is for when we will be exporting the low res afterward. Click OK. And now you can see that our UV shells are all fitting within the 0 to 1 space. Technically, this tool can easily deal with UV islands that are outside of the 0 to 1 space. So you could have things like UDIMs. But again, the limitation that I have said is really the thing that bothers us the most, which is that once we convert this to a low poly geometry, these UVs will reset. We can go back here to our 2D pattern window and we can export our high poly out. So let's go to File, let's go to Export, and let's export this out as an FBX. So let's save this as our high poly. And within our export options, either export this out as thin or thick. This is really up to you to choose one or the other. Our tool will work no matter which one. Personally speaking, though, I would rather export this out as thick. And also I have disabled here the avatar, by the way, so that I don't export this out. This checkbox might be turned on by default. If that's the case, please turn it off, unless you want to export the avatar at the same time. But so your choice of thin or thick really is a question of preference. I like to export as thick personally because I want to keep the final thickness that I may have set within Marvelous Designer for any of these panels. It just gives us a few more steps to do within Blender afterward, but you'll see it's nothing complicated. But anyway, whether you export as thin or thick, you can make it work in both cases. In my case, I will use thick. Once our high poly has been exported, now we can export our retopology. So if we've used Marvelous Designer's retopology tools, we can go here and go to Edit Topology, and then right click on any of the panels that we have created using the topology tools of Marvelous Designer. And then we will do a remesh and replace. Sometimes Marvelous Designer will remesh and replace all of the panels that you have, and sometimes it will only do it one at a time. This is very, very bothersome. So sometimes it will remesh everything in one shot, and sometimes it will only remesh them one at a time. So that's a pretty big problem. I hope this is something that they address in the future. In our case here, we don't have that many panels, so we can just remesh and replace each of these one after the other there. But some type of way to remesh all of these panels once would obviously be extremely useful for us. So now let's go back to our UV editor. And you can see what happened to our UVs. The UVs for the panels that we have retopologized have been reset to their 2D arrangement, which is a problem for us because our UVs absolutely need to match to be able to do this transfer properly. I suppose it means that we never needed to pack our UVs 0 to 1 to begin with. Because if I do here right click and I say reset UV to 2D arrangement, you can see how our panels that were from the high poly now all jump back within their correct position relative to the panels that have been retopologized. So truth be told, we don't even need to actually do a fit all UV to 0, 1 afterward. But I'm a game artist, so I like to fit everything neatly within the 0 to 1 space. Although again, not strictly necessary. And once again, I will do a fit all UV to 0, 1, and I'll make sure that this UV coordinate value that is right here is the same as what it was set before to 0.03. And there we go. We can now export our garment once again from Marvelous Designer, but we are now exporting our low poly. Mind you, you can see that I have my low poly that is in here. So I do have some of these here are low poly pieces. And I still have my high poly that is in here too. So the pieces that I have not retopologized, you can see are still at the high poly stage. So we'll have to separate those out within Blender afterward. Let's go to File, let's go to Export, FBX here as well. And let's export this out as our low poly. In this case here, I will make sure to select Thin. We don't need to merge vertices here. We will do that within Blender together. So we're back within Blender. Let's go ahead here and just delete the default cube that is there. And let's import our high poly and our low poly within the scene right here. So let's go to File, Import, and import FBX. Let's select our low poly and our high poly that we have exported out of Marvelous Designer. We now have both meshes at the center of our scene. Let's zoom in on this. So there's a little bit of tweaks that we need to do to both the high poly and the low poly before we use our nodes here to transfer the details over. But it's nothing really complicated. You'll see we'll be done with this fairly quickly. First of all, on both the high poly and the low poly, I want to reset the transforms. So let's do Control A with my high poly that is selected. Let's apply all transforms. And I will do the same with the low poly as well. Then the next thing that we want to do, this is not strictly necessary, but yet again, I like to do it just to have a mesh that is very clean to work with. We're just going to get rid of all the materials here because you can see that both our high poly and our low poly have a bunch of materials that are applied here. I guess that can be useful in a lot of cases, but in my case, I actually just want to get rid of those. So if I select the high poly then, and I go to the materials tab right here, actually, or material properties right here, you'll see all the materials that are applied on this. So not only do we have the materials that we have created ourselves within Mars Designer, but we also have a bunch of other stuff in here that, to be honest, I don't quite know why they're even there to begin with. So we want to flush all of that. And trying to delete all of these here just by one at a time will be very complicated. So the way we'll do this to just flush all these materials is just go to the object data properties right here, and then go to attributes. And let's take the material index attribute here, and let's just click on the little minus right there. So it's going to get rid of all the material indices on the mesh, which means that now the mesh essentially has only one material applied on the whole object. And then afterwards, let's go back to our material properties and let's click on the little arrow that points down right here. And let's do a remove unused slots. So there's still one material that is applied here, and I could actually get rid of that one too by pressing the little minus here. And now there is no more material applied on our high poly. Let's do the same for the low poly then. For the low poly, I'm just going to go ahead and create a checker texture that we can already apply to it. Let's click on new, and we now have a new material that is applied to our low poly mesh. And to create a checker, essentially, where it says base color then, and we have a little yellow dot that is there, let's just click on that. Select checker texture. And afterward, this checker texture right now does not actually use the UVs. This is actually using some type of 3D projection, I guess. So let's go to vector then, where we can select our actual UV map, but we also want to tile the checker. So not only do you want to select a UV map from this particular list here, but we also want to apply, and first of all, we want to apply a vector math node to this here. So vector, we have selected vector math. And then afterward, where it says add, not the first one, but the second one that says add, let's click on this little drop down menu and select multiply. Then set our first vector by clicking on the little purple dot to our UV map. And our second vector then will be our multiplier. So let's go for a value around, I want this to be pretty small. So I don't know, let's go for maybe 1,000. It's going to be the amount of time that this checker will tile itself. And we can check the checker by switching here over to this shaded preview mode. And yeah, that's pretty good. Let's go back to our high poly then. And let me also go back here to solid shaded. Select our high poly. I'm pressing the divide button on my numpad to isolate only the high poly. So right now our low poly has been hidden because our high poly is now isolated within the viewport here. And so we've exported this high poly out as thick. And I told you that there's a few extra steps that we need to do within Blender. Had we exported this out as thin, our high poly would be pretty much good to go. We could use it straight as is. But as I said, I like to export it out as thick because I want the final thickness, if you will, of the mesh that we have right now within Blender. I want that to be the final thickness that exists within Marvel's Designer based on the thickness values that we have in there. Basically, the transfer node that we will be using relies on transferring details from the high poly to the subdivided low poly through UV space, through the UVs essentially. So, a limitation of Blender's implementation of that, that's essentially the transfer attributes of Maya that we have here, where we can transfer details through UV space. A limitation, though, of that implementation within Blender is that it only works if our UVs do not have any type of overlapping. So within the high poly, the moment that two polygons overlap somewhere, those polygons will not be able to be transferred in any way to the low poly. It's not the end of the world. The mesh is not going to blow up in our face, but it means that if we have overlaps somewhere, we simply will not be able to use that part of the high poly where that overlap is. And of course, because we have exported as thick, it means that now we have overlaps to deal with. So we need to deal with that and just get rid of all the overlaps. Very simple to do. What we'll do here is that we will simply duplicate our 3D viewport by going to view here, going to area, duplicate area into new window. And then we will switch here on the top left of this new window from the 3D viewport to the UV editor. And then with my 3D viewport that is selected here, I'm going to press tab to go within edit mode for this particular object. And now that we are in edit mode for our high poly, we can tweak our UVs or select the UVs that we want to get rid of. On the top left of my UV editor, you can see that I have the UV sync selection that is turned off. And that is important because if it is turned on, we won't be able to select overlapping faces. So it's important to turn this off for now. And let's go here within face selection mode. In this mode now, we can go to select and we can select 0 faces. So right here. And this selects for us all the faces of the mesh that essentially have an area of 0. So if we zoom in here, you can see that that is essentially all the faces of the thickness of the mesh. They're all kind of all stacked on top of each other because although we have added thickness using Morrow's Designer, that thickness was not extended out from the UVs, which means that all these vertices are now stacked on top of each other, and this is just very, very, very bad for us. So with these faces selected then, let's press G, move these out of the way. And let's go back to the select menu, and let's now select all flipped faces, which will essentially select for us all of the back faces or the back of all of the cloth panels that we have. Let's go ahead and also move these out of the way. Let's turn UV sync selection back on, which means that now if I do a selection within our UV editor, it will be mirrored within our 3D viewport. And I can close my UV editor. Actually, let me keep the window open. We will use it later. You can see that I now have a selection for all the polygons that are creating the thickness of the mesh, the way that it has been exported out of Marvel's Designer, and all of the back of the panels that we have. So let's go ahead and just delete that. Press delete. Select faces here from the delete menu. And now we have effectively a mesh that is a thin mesh, just like if we had exported out of Marvel's Designer like so. But yet again, it has a little bit of the thickness that was set within Marvel's Designer through the parameters that is now part of the shell that is in front of us. And that's all the tweaks that we need to do to the high poly. So it's now good to go. We can use it for our detail transfer and have a few little tweaks to do to the low poly as well. So let me go ahead here and select it now. Press again the divide button on my numpad to isolate it. And unfortunately, Mars Designer has exported the low-res retopology. If I press Z here to show you the wireframe, it has exported the low-res topology at the same time as exporting the high-res pieces that were not retopologized. So unfortunately, I have not found a way within Mars Designer to export only the root topology. I haven't found a checkbox that does that. That would be a nice feature to have. It's not there right now, so yeah, I guess we have to deal with that. But it's not the end of the world here. We don't have that many UV shells to deal with. So let's press Tab and to select all of these low poly shells, because I want to keep those, but I don't want to delete everything else. I can put my cursor over one of these UV shells. Press L to select. I said UV shell, but you know, these panels. And so every time that I press L of my cursor over one of these panels, I will add it to my selection. And of course, I could also select these within the UV editor. It might also be a little bit easier, perhaps, to see which are the low res panels from the high res panels. So all of that works really. And let's press Control I, invert the selection, delete. And we have now deleted everything that is not the retopologized mesh. So now we have a choice to make, which is either to weld some of these vertices or not. I've designed this pipeline so that it will make it very easy for us to weld vertices, because sometimes we actually want to do that. We do sometimes create garments within Morphs Designer, and we have a lot of different unwelded pieces within Morphs Designer because it's sometimes simpler to build meshes like these, but we eventually want to actually weld these, right? To have one continuous surface to our low res. So there are places where we want to weld some of these vertices. And so that is what we are about to do. It's not necessary to weld or not to weld. It's really just a question of preference and what you expect to have in the end for your own final low res, I suppose. So let me go ahead here and just do a selection over everything here. So I'm within vertex mode. I'm going to press A to select all the vertices. Press M afterward, and let's do a merge by distance. And then let's tweak these settings here. So this distance a little bit too high. Let's set this down to, this would be 1 centimeter. Maybe that's too low. Maybe that's too high. So about 1 millimeter here, perhaps should be good. So I'm welding essentially pretty much all the points that are already overlapping. And let me check around to see if there's anything that I would like to weld that is not currently welded. Let me go to edge mode here, press K. Could add a cut here. And then add another cut here. And then I can weld some of these vertices here. We can do any changes that we need to do to the low res at this stage. The only thing that is important is that we do not disturb the UVs. That's the only thing that is important, in the sense that we don't want at this point to introduce any kind of UV distortion. Because if we do, then the UV transfer afterward, or rather the detail transfer through the UV space, will start to behave in a bit of a weird way. So if I actually show you the checker here, we can do any changes that we want. We can move vertices, we can add vertices, we can cut stuff. But as I said, the only thing that is important here is that we we don't start to introduce any kind of ugly UV distortion here. So for example, if I want to move a vertex along one of the edges here, if I take a vertex here and I just press G just to do a move, you can see that I'm heavily distorting the UVs. This is going to create some very weird effects afterward once we do the detail transfer using the cloth transfer node. So a better way to do that would be to select a vertex and press Shift V to actually slide a vertex, as you can see, along one of its edges, which actually makes it so that we are, as you can see, also modifying the UVs at the same time. So we're free to do anything that we want, cut the mesh, add vertices, move vertices around, but as long as we keep the UVs very nice, because once again, we're transferring the details afterward in UV space. So it's important that these stay pretty nice. Let me delete this. Let's do dissolve edges here. And then I'm just going to cut from here to there to keep this as quads. Of course, this isn't the cleanest of topologies, but the idea here really is just to have something that we can afterward subdivide in the context of sculpting, really. So I'm not doing any kind of final low res. I would like to be like 100% clean everywhere, right? Just want something that we will be able to sculpt on top of afterwards. So yeah, this worked pretty well. And then let's take these UVs afterward. Let's do another merge by distance on this. All right, I'm not going to bother with the rest, but I think you get the idea here. While we're there, it's not a bad idea to check for any flipped faces because sometimes Marvel's Designer, we don't really take into consideration too much what is the orientation of the panels. So whether the normals are pointing in the good direction or not, that kind of happens. And I know for a fact that sometimes I wind up having meshes where some of the normals are actually flipped the wrong way. So it's not a bad idea while we're there to maybe just keep an eye out for that here. So let's just check the normals that we have everywhere here. So let me go back here to solid shaded mode. And then afterward, while we are in edit mode, let's go in here to our viewport overlays. Let me just turn on here normals. Make sure that we are displaying normals based on faces, size. Let's go for 1 centimeter, perhaps even 0.5. In general, these are all pointing in a good direction. But I'm pretty sure that here, yeah, you can see these polygons here. So these are welded. Uh, our mesh is kind of creating a bit of an S shape right here, but these polygons are actually, if you take a look at the normals, these polygons should actually be pointing the other direction. So these polygons here actually need to be flipped. So let me just go ahead and do that here. Let's go within face mode. I'm gonna hold Alt to select this poly loop that is right here. Let's go to mesh. Let's go to normals. Let's do a flip on that. So feel free to continue working on this. Do any changes that you need to do to your retopology from Mars Designer. But in a nutshell, that's all that we have to do here. Let me press the divide button once again on my numpad to get out of isolation mode. And we can now do our cloth transfer. So very simple to use these nodes. Let's go to our modifier tab right here, modifier properties. Let's add a modifier to our low poly. This will be a geometry nodes modifier. And let's click on new to create a new set of geometry nodes. Then let's go to that window that I kept open. That is right here. So this is to our UV editor. On the top left here, let's go from our UV editor to our geometry node editor. And we have then our input and our output for our current geometry nodes that we have created here. So super simple. Let's just move the group output out of the way here. You'll see this is very simple to use, okay? Let's just press Shift A to do a search. And then click on search here. Search for Algang. Let's add Algang cloth transfer. Let's do another search. Add Algang cloth thickness. Hook these up. Also connect the subdivision value that is right here. And subdivisions here, let's set this to 4 perhaps. And then where it says high poly here, so the high poly input box that is right here, let's just click on this little drop down here and select high poly. There you go. Why don't you look at that? This is our low poly geometry, but we have subdivided it and transferred all our details from the high poly to this new topology in the process. And we also have our thickness that is right here, as you can see, with the required amount of edges on the border so that we can reconstruct this afterward either within ZBrush or within Blender for detailing. By the way, let me just press N here to open this little menu here on the right. Let's go to View, and let me just set the camera clip here to add another 0 to this so that we can zoom in a little bit closer to this mesh. But yeah, right. So in a nutshell, I mean, it's really as simple as that. It's really not that complicated. If I turn off the geometry nodes here, you can see we're back at our low res. Turn this back on, and we have our low res that has been subdivided and all our details there. Super simple, right? So that's it. Class is done. Thank you. No, I mean, it kind of is in a way, but I actually want to take some time with you to really go through all of the options that we have here within our nodes here. So within the Algang cloth transfer node and the Algang cloth thickness node, you can see there's a bunch of options in both cases. And so I actually just want to explain all these options one after the other there, or at least the options that are here within version 1.0 of these nodes, in case that you decide yourself to use these. Of course, perhaps another thing too, it's not strictly necessary for you to do this, but um, because we have these two nodes that are connected together there, it will slow down any changes that we would want to do to these nodes, perhaps a little bit. If I play with the thickness here, you can see it's actually a little bit slow because we probably have to go through the whole graph at once. Although it's really not that bad, really. But there's really nothing that stops you from, let's say, only doing the cloth transfer first, outputting that out, and then just tweaking the settings here. And now that I have disconnected the Algang cloth thickness node, you can see that now we do not have any thickness anymore, but we are still transferring the details over. So perhaps there's tweaks that you want to do in between those two nodes, or maybe you just want to apply these nodes one after the other there. That is perfectly fine. However you want to do that, you can definitely do that. Apply only one node, and then once you're done with the Algang cloth transfer, go right here, do apply, which effectively applies these geometry nodes. So now you have baked in the detail transfer from the high poly to this mesh now. Apply a new modifier, new geometry nodes, and then apply only the cloth thickness here. So you can definitely do that, but in our case here, I'm actually just going to do Control Z, and we're going to keep them both hooked up because they are synergistic nodes. As you can see, the subdiv value here, we can actually hook it up because the subdiv levels that we have controls the amount of edges that are added to the thickness. You know, for the Algang cloth thickness node, the subdiv levels, we always wanted to match the same level of subdivs that we have added to the Algang cloth transfer, because that is what will allow us to, in turn, afterward, cleanly reconstruct this mesh either within ZBrush or within Blender to do an unsubdivide with a multi-res node. Okay, let me close this window actually, and we will open a separate window here just by doing click and drag here on the lower left of our main 3D window. And just doing click and drag right here, and then afterward on the top left, switching over this editor here to the geometry node editor. And let me press N here to close the right tab. Okay, so I want to explain with you what all of these options do so that you have the full information at your disposal to use these nodes properly here. So let's go through all of these options one after the other there, starting with the Algang cloth transfer node. So in here, there's really not that many options, but it's still kind of crucial that you understand what they do. Subdivisions, as we have said, essentially controls the resolution of your mesh, of course. If this is back down to 0, then we are essentially back at our starting point. And we can set this as high as 5 subdivisions. It didn't seem to me necessary to expose a 6th subdivision level because already at number 5, you'll see that it starts to slow down significantly. And besides, the data that we export out of Maros Designer is typically never high res enough that a 6th subdivision level would really make much of a difference, really, in terms of details. Because you can see, even at subdivision number 5, we're starting to get this kind of faceted look on the surface, and this is actually coming from the fact that the high poly is now actually of a lower resolution than this subdivided retopology that we have here. And because of that, we're starting to see the faceted effect of the actual faces of the high poly there. So I have exported the high poly out with a particle distance of 3, by the way, within Maros Designer. If I brought it down to 1, this would probably be a lot better. But still, you know, like I don't think that we often would want to go over 5. But at the same time, I mean, if this is a feature that some of you would like, if you think it's really important for you to have access to a 6th subdivision level for any kind of reason, let me know, and we can. I can see what I can do about that. Border bias and bias algorithm. These two, they kind of work hand in hand, and these are actually perhaps a little bit more subtle to explain. So I will try my best here. The default value of border bias is 0.3. And if I actually take this value and I put it to 0 instead, you'll start to see that we're going to start to get some strange behaviors around the borders of the mesh. So I've set my border bias to 0. And if I zoom in here, you can see that we're starting to get some kind of strange artifacts here over the border right here of the mesh in different places, and also places where we actually had seams. This is the front of the coat that is right here, and actually within Marvel's Designer, you would see that these two sides are actually separated. I can show you actually what that looks like. So these are actually two separate sides that are essentially separated. So they're two different panels that are welded. And also on the border of the mesh, you can see that some places we're getting these kind of weird spikes there. And the reason for that is if I actually take the low res here and I take the high res at the same time, so I take those two meshes and I press tab here to go within edit mode. And I go back to the UV editor. We are transferring details through UV space. And actually, why don't I also turn off the normals so that this does not look like it's a little bit fuzzy. So we are transferring details in UV space, which means that it is obligatory, of course, that there are UVs for the high poly and the low poly that are stacked on top of each other to be able to transfer the details through the UV space. And so, whenever that is the case, when our high poly and our low poly have UVs that perfectly match, we get the detail transfer working flawlessly. But around the borders, that's not always the case. So, if I actually zoom in here within our UV editor, you'll see in certain places, like here, actually, it's a pretty good place right here. Because this low poly is, of course, of a lower resolution than the high poly, there are little gaps sometimes between the border of the low poly and the border of the high poly. And so where there is no high poly that is overlapping the low poly, Blender cannot really solve that. It does not really know what to do with those particular vertices that are over the border there, where there is no overlap of the UVs between the high poly and the low poly. And as a consequence, Blender simply cannot project stuff there. And so I had to come up with a solution for that. And the solution that I came up with is this bias that I have shown you here. This particular bias here, what this essentially does in a nutshell is that for polygons and vertices that are over the border, either on the border of the mesh or where there are UV seams, what Blender does is that if it cannot find a match for the vertices there, this bias is essentially a bit of a search distance where these vertices will start to search inside of their respective UV islands for whichever point on the high poly they come into contact with. And so this bias value controls how deep within each UV shell, which will these vertices that are over the border search for a match for the high poly. This is a value we want to keep relatively low. If it's very high, it starts to create other problems. In my experience so far, a value of somewhere between 0.1 and 0.8 seems to give some pretty good results. And if I set here just the value here just to perhaps the 0.1, and I have actually gotten rid of these little artifacts that we have here. So that's essentially what it does. We had the same thing here between right here, actually. I set this back down to 0. You'll see here once again what is happening. I have a few of these vertices that are essentially not behaving properly. So the border bias here cleans that up. A value 0.1 might not be enough in your case. It might even be too high in your case. The idea is that you want to play with this value here. If the default value doesn't seem to give you a pretty good result, you want to play with this particular value until you get all the vertices on the border or on the UV seams to look as good as you can, really. You can see here we have still a little bit of a problem here, in fact. So let's try a higher bias value. So 0.2, we see we're kind of almost there, but not quite. So let's go back here to 0.3. And yeah, that looks pretty good. So I have maybe a bit of a artifact here. We could try 0.4. Yeah, that's pretty good. But you can see that if this value starts to become too high, we also start to have other artifacts perhaps that are starting to appear. So you want to keep this value as low as you can and kind of find the sweet spot for yourself. What is the bias value that will give you the least amount of problems, so to speak? So that's what border bias does. And the other bias value that is right here. So this is bias algorithm. This is basically because I kind of found two different approaches to solve this particular problem. And I couldn't really make up my mind as to which one was the best one because they both had their strong points and their weaknesses. So I decided to just give you the option instead. So this bias algorithm is essentially either 0 or it is 1. And it will simply use a slightly different way to calculate this particular bias that we are talking about here. And in certain cases, one will give you a better result, and the other cases, the other one will give you a better result. It's mostly a question of precision in the sense that if you take a look here, so there is actually a seam here. This particular part of the mesh is a separate panel, yet again, than the rest of the torso. If we were to look at this in Marvel's Designer, this would become very clear to you. So we're talking about this panel and this panel here, and there's a seam in between. And so this particular bias algorithm set to 0 typically leads to a little bit less problems, but the drawback of it is that it doesn't quite deal as well with seams, as you can see. So we have a seam here with my algorithm set to 0. This seam is a little bit there. It's kind of a little bit visible still. But if I set my best algorithm to 1, then this seam will completely disappear, as you can see. So bias algorithm 1 is slightly more precise, but it has also sometimes the drawback of actually creating few other artifacts in different places. If you look at the border here, bias algorithm 0 here gives us a slightly better result. So it's all very subtle, it's all very minor, but sometimes one will give you a better result than the other one. So just play around with these two and with the border bias value until you pretty much get something that is exactly the way that you want it to be. I'm going to go ahead here and just get rid of the thickness just for now, just to speed up Blender a little bit. And so that's more or less all that we have to talk about here for the Algang cloth transfer node. Perhaps the other thing that is important here to mention is that if you take a look, okay, so some of these edges are becoming smooth, whereas some of these edges, I perhaps want to actually keep them as sharp. So if I show you what the high res looks like, these corners here completely sharp, as you can see. And perhaps there are other edges elsewhere that I would like to keep sharp as well. So I have made it so that we do have the option of doing that. If I select my low res here yet again, and if I, for now, just simply turn off our geometry nodes, just let me just turn off the display of those. I can actually go with an edit mode and I can select some of these edges here. So these edges here, I can select those and then I can go to edge and I can do a mark sharp edge. And this will make sure that these edges will stay completely sharp after subdivision. If I turn on my geometry nodes here yet again, you can see that now these edges have stayed completely sharp. Can do the same thing, let's say right here. I also have a border here that is becoming smoothed in the way that I don't necessarily want it to be. So let me press tab, go with an edit mode, select this edge here, and yet again, let's go to edge. Let's do a mark sharp. I can do that in different places. Here, perhaps I also want to keep a sharp edge, perhaps. So same thing, press tab. In this case here, let me hold Alt to select the full edge loop. And I can mark this as a sharp edge. And there you go. We now have nice, clean, sharp edge, even after our transfer is done. So let's now talk about the outline cloth thickness node. Just to speed up Blender a little bit, I'm just going to collapse now the outgang cloth transfer because I don't feel the need to go back. Let me go ahead and do that then. Let me apply my geometry nodes. And then let's create new geometry nodes. And within our geometry node editor, press Shift A, press search, type in outgang, and let's add outgang cloth thickness. And let's talk about those options now. Now, because my outgang cloth thickness node is not hooked up to the outgang cloth transfer node, I now have to manually set the subdivision levels. And so if you don't set this value properly, we'll make it so that you won't be able to reconstruct all the way down to your lowest subdivision level afterward, either within ZBrush or within Blender. So as much as possible, try to set this value to the same subdivision levels as what you had on your outgang cloth transfer node. In my case here, that was 4. And as I've said, all that does is that it adds subdivisions to the thickness itself, as you can see. And it gives you the required number of edges that you need to be able to reconstruct this afterward. And here too, you can go up to 5 subdivision levels, and it didn't seem to me necessary to be able to go higher than that. Thickness is pretty self-explanatory. That is the thickness in millimeters. I set this to 1, of course, it will give us thicker cloth, as you can expect. Thickness offset is whether the thickness will be pushing inward, pushing outward, or will be pushing both inward and outward at the same time. With a thickness offset of 0, the thickness is only pushing inward. So if I set this to 2, let's say, you can see that now my thickness is only pushing inward, which is actually what I prefer, especially since I have used a high poly that had been exported out as thick. I actually now only want to be pushing inward because my high poly essentially already had the outside thickness, if that makes any sense, that I already want. So I don't want to add thickness on the outside of the cloth more than that. But if I had exported the high poly as thin from Maros Designer, then likely I would want to set the thickness offset instead to 0.5, which will make it so that the thickness will be added on both the inside and the outside at the same time. So we will be pushing in both directions. And finally, if our thickness offset is set to 1, then we will only be pushing outward with the thickness. But I don't really like that because it tends to just make the cloth look a little bit bloated. So that's why I would rather push inward rather than push outward. Our profile style is essentially a way to to choose a different shape for the profile here that we are creating. So by default, the value 0 creates a rounded profile. And also while we're there, actually the profile amount controls the how strong is that particular shape, by the way. So let's say that we set the profile amount and we bring it back down to 0, we can see that now we have essentially a hard edge for the border here. And so our profile style allows us to choose different shapes for our profile. We can either have the default or we can have this one, just kind of a like a double profile, which is essentially what happens if you set a garment panel as double-sided within Marvelous Designer. You'll get the exact same look, which can look cool if you want to kind of make it look as if two pieces were actually sewn together. This makes it look pretty cool. So that's a nice way to do that. And finally, if you set your profile style to 2, what you will get is a square profile, but with rounded corners. So you're getting a square profile here, but you're not getting completely sharp corners. You're getting a bit of a rounded corners there. Also, just a note here. These hard edges that you're seeing here are not added by the nodes. This is actually just coming from the object data properties. So let me select our mesh here. Let's go to our object data properties, and then let's go down where it says normals. Let's turn off auto smooth. There you go. Or we could set it here. It's not bad to keep it perhaps on these corners. So maybe we'll set it over to 60 perhaps. Yeah, that looks a lot better. So that's our profile style and our profile amount. And UV padding multiplier and UV seam placement. For these, to see what these do, I'll just turn on the rendering yet again of our checker. And so what this does here, the UV padding multiplier is that if I set, let's say, this value here a little bit lower, you'll see the kind of effect that it does here, perhaps 0.5. It simply just gives a slightly different stretch to the UVs here. So the UVs that we have, the will expand following the thickness of the cloth. So if I set my cloth thickness to maybe 2 here, you'll see that our UVs expand at the same time. But we do need some type of multiplier here to make sure that we are always getting UVs that are distortion less. And so it's the kind of thing for which value is kind of necessary here so that we can just manually inspect ourselves the UVs and make sure that we are removing all of the distortion here from the borders. And finally, the UV seam placement. We need to have a seam somewhere on this particular garment for the UV seams. So by default, the UV seam is placed on the underside of the garment. As you can see, we have a UV seam that is right here. But I've also made it so that you have a second option at your disposal. And if you set this particular value here to 1, you will get the UV seam instead to be in between, or rather where the thickness is. You can see you get the UV seam that is right down the middle. Because I think in some cases, maybe that will give you a more preferable result depending on what kind of style you're trying to go for. It makes it so that the underside, if the underside will be visible, now does not have a seam there. So in certain cases, maybe that will be preferable for you. And this particular UV seam placement set to 1 works very, very well, by the way, if your profile style is also set to 1 there, because you are getting the UV seam that is right within the sandwich in between those two pieces that seem to have been glued together there. Anyway, so these two work really, really well together. And depending on the kind of effect that you're trying to go for, UV seam placement here, either set to 0 or set to 1, might be preferable for you. Finally, the last option here is keep underside. This will simply, if you turn this off, this will simply erase the underside polygons because you don't necessarily always want to have those. Maybe there are cases where you would rather get rid of those. Perhaps for optimization purposes, or maybe they will create issues for you sculpting wise. Don't know. Maybe you just don't feel that you need them for some reason. So you can get rid of this little checkbox to also delete these polygons in the process. And that's all that you need to know, really. So once you're happy with everything, go ahead and collapse your geometry nodes. And in fact, there's actually a little bit of a problem here. Let me take a look at that here. I think this is actually coming from the thickness, which is actually a little bit too high right now. So I've set the thickness here to 2 millimeters, which is actually more than what I had within Marvel's Designer. I actually had a thickness of 0.5 in Marvel's Designer, which is why we're starting to get a little bit of this crash through here because I've just made the cloth a lot thicker than what I originally had here. So if I set this, let's say down to 1 perhaps, you'll see that, yeah, if we take a look here, see that now we're getting our cloth is nicely folding upon itself, but does not actually interpenetrate because the thickness is a little bit closer to what we had within Marvel's Designer. Of course, ideally, you would set this particular value here, this particular thickness to the exact same value as what you had within Marvel's Designer. But that's up to you to make that choice and to play around with that value if you want. And of course, you can always split your retopology into multiple objects, and then you can apply different thicknesses to different portions of your garment too, of course, if you want to have different portions of your garment that do have the impression of having different thicknesses, you're free to do that, of course, as well. So that's all that you need to know, really. Let me go ahead then and close this extra window that we have here. And we can now either work on this, continue working on this within Blender, or we can export this out to ZBrush. If we want to sculpt on this now within Blender, it's now very simple. Let's go ahead and apply a multi-res modifier on top of our collapsed retopology. And we can now unsubdivide until we get back to our original low poly. So here we are at number 4. You can see we have our thickness that is right here. Everything is looking pretty good. Set our sculpt here back to 4. Viewport level here back to 4. And I can go now within sculpt mode if I want. And I can sculpt now on this. I can shift here just to delete this visible seam that we had here. And you're now free to do whatever it is that you want to do with this. We will continue working on this garment. By the way, after we are done together with the Marvelous Designer stage, we will continue working on this within Blender. That will be my preferred software to continue working on this. So if you're interested to see how we can continue tweaking a garment after Marvelous Designer using Blender and sculpting a few extra details here and there, that will be what we will do together there. But of course, if our goal instead is to throw this over to ZBrush, we can also do that too, of course. I can now export this to ZBrush too, of course. Let's go to File, let's go to Export, export this out as an FBX. I do recommend that you use FBX because the OBJ importer and exporter of Blender does not seem to always deal with scale very well. I've kind of seen, so FBX for me is always safe as an export and import format for Blender. And here let's select only limit to selected objects so that we're not exporting the actual original high poly at the same time. So we're now within ZBrush. Let me apply a cylinder here to my canvas. Let's go to Tool, Import, select the FBX, and here we go. We are now within ZBrush. And here now, let's go to Geometry, and we can reconstruct all the way down to our lowest subdivision level. And as you can see, we can here too sculpt some nice details on top of this. And we can subdivide this even higher if we want to, of course. So there you go. I think this works pretty well. I hope this will make you very happy. I've worked quite hard to get these geometry nodes going and to be as flawless as I could get them to be. And I hope that these will be extremely useful for you in the future for any kind of work that you will do that involves Marvelous Designer, whether that is to export it out to ZBrush afterward, to Blender, or just to render it out and just to have some proper UVs going on your borders there so that you can apply some type of detail map that will tile on top of this. You can also, we haven't really talked about that, but you could obviously now export this out to Substance Painter directly too, if you just wanted to go straight from Mars Designer or to Substance Painter and to continue working on your garment in there, or to texture it directly, you can do that too, of course. So all of these options are now at your disposal of this particular workflow. So I hope it is very, very useful for you. If you do encounter any bugs and you would like to report them, or if you have any suggestions for any future features that you think we could add to these geometry nodes to make them even more useful for you, please do either leave a comment down within the comments of this particular class or send me an email at info@outgang.studio with your ideas as to how we can improve these. And I will see what we can do for future versions of these nodes that will, of course, be distributed to all Outgang members. So by being a member on the website, you will always have access to future releases of the Outgang cloth transfer nodes. Before we wrap it up, I wanted to take a few minutes to show you how retopology works within Marvelous Designer so that we have all of the information within one class here that is at your disposal to do your retopology from A to Z using Marvelous Designer. So let's go back to Marvelous Designer and let's talk about that. Okay, so I have this garment for which I have already created a retopology. By the way, if you already have retopology that has been created for any of the pieces that you have within Marvelous Designer, you can put your cursor here on the top left where there's a little shirt icon and just go down to the bottom here and you can show topology. And so if you already have topology that has been created, you will be able to see it like this. So you can turn on and off the display there. And within your 2D pattern window, if you want to see the topology, just select one of these options here. So put your cursor over the icon that looks like a little bit of a grid. Once again, perhaps it's worth to mention we are within Marvelous Designer 12 in this particular case. That is important because this is the release that has these tools in there. And so let's say that I click on Edit Topology here. I can see the topology that I have previously created. Anyway, I'm just going to go ahead here and do a box selection. I'm just going to delete everything that I have previously created, and we will create together part of that. And I will show you how that actually works. Before we do a little bit of a demonstration together, though, I just want to tell you a little bit about all the tools that are at your disposal so that you have the full information here before we start to work together. And so here we have essentially three options, as you can see, as we put our cursor over this particular grid like icon that is right here. By the way, you also have the chance to edit and create topology within the 3D window directly as well. So within our 2D window then, so we have access to essentially these three functions. And let me just detach this particular menu. The most likely start point that you will want to use is the patch topology that is right here. This is actually very simple to use. None of these options are actually very complicated. The topology tools of Marvel's Designer 12 are very basic. I think they're pretty useful. They're certainly useful in the context in which we are using them, but they remain pretty basic. So we're not going to do any kind of crazy topology with this. We are certainly not doing what would be a final low res and on which we want to spend days. I really see these topology tools of Mars Designer more as a quick aid to be able to extract a clean enough topology for the purposes of sculpting afterward or rendering out, but not necessarily to make what would be a low res that we would want to throw within a video game afterward. I mean, I suppose technically you could if you're really motivated, but you'll see that it can get a little bit bothersome sometimes using these tools on meshes that are very detailed. There are some, I wouldn't call them bugs, but let's just say limitations that make it so that this is a good tool to use to generate quick topologies, but not necessarily one we would want to spend a whole lot of time with to create very detailed and very precise ones. Anyway, so patch topology, very good starting point. What it allows you to do is just to select, first of all, patch, which will be highlighted here in white. And afterward, put your cursor here, and you can see that your cursor will actually snap to either internal lines or to borders of the panels. And once you click and drag, you will be able to create some of these blue lines. As you continue to click and drag, eventually you will be able to create big quads. So once you create four edges like these that wrap around and connect with each other like that, you will be creating what is essentially a patch. Within that patch, we'll be able to subdivide that to add cuts in on whichever edge that you want. Actually, you can see here on the top right that there is a patch retopology box that has shown up the moment that we have switched over here to patch topology. And here it says 1 right now. So as I increase this here, it will actually automatically add a certain number of subdivisions on these edges. But it's actually better to increase this number before you actually start to draw any type of patch. So let's go ahead here and set this to 4 subdivisions. And now as I use my patch topology tool, and as I close this patch, we will have topology that will be automatically created on the inside of that. Now, I'm saying automatically created, but these are actually still preview points. As you can see, this is not actual topology yet. So the idea is to let you actually create a few of these patches that are all connected to each other. And to keep doing that until you've covered most of the panel on which you are working. One thing to note, okay, is that actually I can actually select one of these blue edges as my patches are still active, and I can tweak the number of subdivisions. And you can see that the patch kind of automatically sort of recalculates itself to make sense of the topology that will be within there. This is actually quite useful in certain cases. So I'll show you a case later on where this is actually very, very useful. Of course, if I just take a random edge and set it to 3 or to a different number, it starts to create topology. It's a little bit weird. This still works well and would work well in our case, but there are actual practical uses for this that we'll see later on. But so, in a nutshell, the idea is that you want to create as many of these patches as you need. Perhaps I can create one or two more of these here. Of course, it's always a little bit of a puzzle, right, to solve these. But if we keep in mind that we're not doing like a quote unquote final low res, but we just want a low res that is quadrified and relatively clean for the purposes of sculpting afterward, then I think it removes a lot of the pressure of doing like some type of extremely clean topology here. So this is actually starting to. I think this will actually work pretty well. Obviously, we have to create patches that have four sides. We cannot create patches with five sides, although we can create patches with three sides. So this here would work, but we cannot create pentagons. So it's always a little bit of a puzzle to solve these. But I think something like this would actually work quite well. Anyway, so that's the patch tool. And once we're done patching up a particular garment panel, then let's click on create here, which will actually convert this to actual topology that we can now also see within our 3D viewport. As you can see in the process, we have ghost points that have been added on the connected panels. So if you have points here that are overlapping an edge of one of your panels, and that edge is seamed to another edge on a different panel, you will see ghost points that will appear, which are simply there to help you place points on the other panel that will be right next to it so that you can easily line up vertices. These are not vertices that already exist. This is just a display to help you place your points so that you create topology with vertices that nicely line up. But it's not necessary to respect those. And these are not vertices per se right now either. They are just points in space. You can see here, actually, if I use patch topology and I start, let's say, from the bottom here, and I create another patch that has 4 points, you can see that I can't ever really completely line them up because well, my first point does not actually match exactly in terms of position here. But I could create a patch starting from here and with, let's say, 4 points, align these relatively well together, as you can see. Could create something like this, let's say. But my points are not have not snapped together, so you'll have to do that manually. So that's the patch topology tool. Then we have edit topology, which allows you to move some of those points around. So some of those ghost points you can see kind of suggest that perhaps this vertex should be a little bit higher. This vertex should be a little bit higher. So I can take vertices when I'm in edit topology. If I press Y to access it, I can take vertices and I can move them, as you can see. And as I move them, I can move them until they are overlapping with those ghost points. You'll see that those ghost points actually disappear the moment that your vertices are not exactly on the edge. So if I take, I don't know, let's say this particular point right here, and I move it off just slightly off of the edge, the ghost point will actually disappear on the connected panel. So sometimes that might happen that your points, you think that they're right on the edge, but they're not. So sometimes just tweaking points so that they are directly in contact with the edge will make them appear on the other connected panel. Edit topology allows us to, as the name implies, edit the topology around. We can take points, we can move points, we can move points very close to each other, and then do a box selection, right click on them, and then do a merge to merge them together and create a triangle. And we can also select edges and we can move edges around. I haven't seen any kind of relax brush for topology. So it would be great in certain cases, maybe here to use a little bit of relax brush, something similar to that on this particular zone here of the topology. I haven't really seen any function like that within Marvel's Designer. So this edit topology tool is pretty basic, as you can see. But we can do all the basic manipulations that we would want to do. If I select a point and I press delete, I can delete it. If I double click on an edge, I can select the whole edge loop if I want to slide that edge loop around. And I think that's all the functions that we have at our disposal using the edit topology here. If we now click on create topology, as the name implies, this is to allow us to add geometry or add topology that does not already exist. So this tool works actually pretty well. We can actually create polygons here by starting from a vertex that already exists and then doing a click and drag. And as we click and drag and we close off the shape that we're creating, we will be creating a polygon within the inside of the shape that we have just created there. I can also click on an edge and do a click and drag. That will allow me to cut through the geometry, as you can see. We're not limited to quads. We can obviously create triangles as well. And that's mostly it. We can do our edits within the 3D viewport as well, as you can see. Sometimes that may make it a little bit easier to line up some of our vertices or see a little bit better what we are doing in certain cases. So those tools work relatively well, but they are very basic. Ultimately, we're not going to do any kind of crazy long complicated retopology with these tools. But for the purposes of creating a clean low res that we can afterward subdivide and use for the purposes of sculpting or rendering out, these work relatively well, I think. So basic tools, but they do the job. Our goal really isn't to spend a whole lot of time in here. It's really just to get something very clean and very fast. Where it gets a little bit more complicated, I think, is let's say that I want to use the patch topology in this particular case, and I want to continue here. So I have 1, 2, 3, 4 edges here that are all connected. So I can set my subdivisions here for my patch topology to 4. I can't quite just draw like this, as you can see, from one point to the next. And so to create a patch that starts from this particular open edge and goes all the way up top, I can't really quite do that. The patch topology is great as a starting point, but once you start to edit topology and create topology manually, it becomes very, very hard to use the patch afterward. Can still use the patch on certain zones here. And what I could do is perhaps something like this here, perhaps, if I wanted to create a patch that had, let's say, four edges on each side. I could create a patch like this, and then afterward, I could go with an edit topology, take these points right here, do a merge on these, select these points, do a merge on these. And so I could combine the patch, of course, with something that has been previously created. But you can see that it already starts to show a little bit of its limitations here. As I said, the goal really here really isn't to spend a long time to do any kind of very complex, very detailed retopology. We really just want to use these tools to generate something relatively quickly that we can afterward use in the context of the geometry nodes that I have shown you, and to continue, let's say, sculpting details on top of this mesh afterward. But for what it does, even if it is very limited, I've said this before and I'm saying it again, even if these tools are very limited, they're still actually very useful because they still allow us to do something that we really couldn't do easily, which was to generate a somewhat clean topology relatively painlessly. And especially, I especially like this ghost point feature that we have here because it does allow us to nicely see where these points should be so that they are nicely lining up with vertices on the other panels that we have. But yeah, I think at a minimum, something I would really like to see in here would be some type of relax brush. I think that would be very, very useful if we could even have that at the very least, so we could just create a few points here and then use a relax brush just to kind of nicely uniformly spread out some of these vertices. That would be a great addition. So our goal really when we are creating topology like this is just like if we were creating topology in any other softwares for the purposes of sculpting, we want to keep it as much as quads as much as we can. Triangles here and there are fine, but we don't want a triangle soup necessarily because quads really ultimately are what subdivides the best and gives us the best sculpting experience afterward. So the same rules apply here as they would apply in any other context when we are generating a mesh for the purposes of sculpting. We want to keep polygons that are relatively square and relatively uniformly spaced and quads as much as possible. I wanted to talk quickly about the patch topology and the idea of setting a different number of subdivisions here for some of the borders that we have here. And that's actually very useful because in certain cases, I might have, let's say, these kind of patches here that are kind of very long on one axis. And the patch topology is actually great, okay? Because what we can do here is we can do something like this here. I can create a topology, a patch topology like this that goes all the way around the shape. And then afterward, well, if Marvel's Designer allows us to do this, but let's see where this leads here. Then afterward, what I can do is to select, let's say, this edge here and set the number of subdivisions here down to, let's say, 1. Select this edge here, set the number of subdivisions down to 1 as well. And now you can see we're actually getting very nice topology for this curvy piece here. And I could even set the number of subdivisions here to be a little bit higher. Just like so. So we can get a pretty nice amount of subdivisions going for some of these strips here, even if they are curvy, just by playing around with the patch topology. So that is actually very, very useful for us. And once again, I really love the addition of these ghost points. So I can actually continue what I have started here. If I wanted to, let's say, now continue the retopology of this piece, like so. Once we're done with the retopology of a garment and we are ready to throw it to Blender for the next stages in our retopology and our export out of Marvelous Designer pipeline, we will eventually want to convert this. So we have done this before, but just as a refresher here. So this is topology that is still in the preview stage, quote unquote, because this topology does not actually exist as geometry within the scene. It's just there as a preview. If I actually get out here of topology edit mode, you can see that this topology is not here. If I go back here within, and I select my select move tool here yet again, you can see that that topology is not actually there. The good part about that is that I can actually still continue tweaking some of these panels. If I think that this particular panel and I move it around, perhaps I can even rotate it, you will see that our topology will actually update itself. So it will follow the changes that we are doing to the panel itself. Now, I'm pretty sure if I start to edit the actual panel, I will probably destroy the topology. But it's also good to know that if you do move some of these islands around and you rotate them and stuff, the topology that was connected to the panel will follow as much as it can. And so if we do want to convert this to actual geometry that will exist within the scene, we simply go to Edit Topology, right click on one of the panels, and do a remesh and replace. Unfortunately, this does not do it on all the panels. As you can see, it kind of have to do it one panel at a time. Again, that feels like a severe limitation, like they haven't really tested their own tools. But unless you have thousands of panels within your scene, it's not going to be that long to convert them all independently. You can also do a remesh duplicate. But in this particular case, you will have both the low res and the old high res that will be overlapping, which might not necessarily be a bad thing, perhaps, but I also think that it makes it a little bit confusing sometimes. And if you are to export this out, this might make it more confusing more than anything else, really, to have your new topology and your old topology both overlapping on top of each other. So that's how we use these tools. It's not a full demonstration necessarily of retopologing this whole thing, but if I show you what it actually looked like here, so the final topology that I had used for this here, if I bring that back, this is what the final geometry actually looked like. Of course, this is not for the full garment. When I'm done with this particular jacket, then I will do a retopology of the full jacket. But as a preview mesh and as a mesh for testing purposes, this was good enough and quite useful. And for the other shirt that I have also shown you here, this is what the topology of it winded up looking like. And you can also see the topology here that I had created for the laces. And you can see that the mesh was actually quite dirty, you know? Like I have these, I have all these pleats here over the shoulder. And yet if we look at the topology that is there, you can see that the topology here was actually quite dirty with a bunch of triangles in here. And these are actually, yeah, these are just triangles here. So this is just a triangle here. This is just a triangle. I have a bunch of triangles intermixed with a bunch of quads in here. It's actually quite dirty, and yet, so this is where my pleats are. So this is quite dirty as a geometry, and it does not really follow the pleats at all. And yet, after I had done my transfer here, I really had some beautiful pleats left after that, as you can see. So all in all, this workflow I think is really solid, and I look forward to seeing the kind of work that you do with these in the future and how useful these are for you. So let me know if you find these extremely useful. Let me know in the comments of this particular class. And I would also love to hear from you. Don't forget to send me an email if ever you have suggestions on how we can improve these nodes in the future for future versions of these nodes. If you have any ideas there, or if you have any bugs that you encountered that are pretty nasty, and things that you would like to mention there, or things that you think could be fixed, also let me know. And I look forward to hearing from you in the future. Thank you so much for watching this particular class. I hope that these nodes come in handy for you in the future. Thanks for watching, and take care.